Hey gang, welcome to Chapter Three's lecture, and this is the Soil Classification and Survey chapter. Let's go ahead and get started here. Before we dive in, let's quickly look at what we aim to achieve today. By the end of this session, you should be able to describe the current USDA soil classification system, explain how soil surveys are prepared and used, and list soil capability classes. These are practical skills and knowledge points that will be invaluable in your natural resources career and throughout this course, of course. So why do we bother classifying and surveying soil? It's not just for academic exercise. The history of the United States, particularly in the late 1800s, show us the devastating and consequences of poor land management, leading to significant land degradation. This realization sparked the modern conservation movement. To effectively conserve and manage land, we first need to understand it. That means having a standardized system for describing, naming, and classifying soil. Soil classification isn't just about naming. It helps us understand, remember, and communicate knowledge about soils effectively, providing essential tools for soil professionals to survey the land and document their findings. The concept of soil classification isn't new. It has roots dating back to the late 19th century. A pivotal figure was the Russian soil scientist V.V. Dukochev, who around 1880 proposed that soils are natural bodies created by what we now call soil forming factors. Remember that list? This idea laid the groundwork for the classification systems that began to be used in the U.S. soil surveys. Over the years, the U.S. system has evolved significantly. In the 1920s, Marvett of the USDA developed a system based on soil properties and the presumed soil forming factors using terms like podzol soils and Chernozem soils. Great words to try to say. You might still encounter these names in older literature, luckily not so much, or in classification systems used by other countries. However, the system we primarily use today in the United States is the USDA soil taxonomy. It was first introduced in 1960 and then republished in 1975 as Soil Taxonomy, a basic system of soil classification for making and interpreting soil surveys. That's a mouthful, which forms the basis of our modern understanding. What sets the soil taxonomy apart from earlier systems is its focus. Instead of presuming a soil's history, it classifies soils based on their observable properties, things we can see and measure in the field or in the lab. Think of it like the way plants and animals are grouped into a hierarchical system, moving from broad categories to very specific ones, like species. Conceptually, it's similar, although there's no direct correlation between the levels of soil and biological taxonomy. The system is dynamic, though. It continues to evolve, with the most recent major addition being the 12th soil order, the Gelisols, in 1998. Just like plant taxonomy, everything keeps changing, but soils not as rapidly. So let's break down this structure. The USDA soil taxonomy organizes soils into 6 levels of classification, from the very broad to the extremely specific. At the top, we have soil orders. There are 12 recognized orders, and these are the broadest groupings. based on the presence or absence of certain key layers in the soil profile, called diagnostic horizons, as well as average temperatures and rainfall, aka climate. Below orders are suborders. There are about 66 of these, and the members of the same order often differ here based on moisture or temperature. Then come the great groups, over 300 of those. These are often distinguished by the presence of specific horizons or other traits. Subgroups, a lot of those, 2,000. This level describes how a soil is to the central concept of its great group. For instance, a typic subgroup perfectly matches the central concept. Then we have families, over 8,000 of those, which group soils into similar properties important for plant growth and soil use, like particle size or what minerals make them up. Finally, at the most specific level, we have the soil series, with over 19,000 of those. This is the taxonomic unit with the narrowest range of features. Each series is unique and is named after where it was first identified, like a town or county. This is the level that local users, like farmers or builders, are most concerned with. Same with natural resource professionals. Sometimes a series can even be further subdivided into phases based on management factors like slope or erosion. Think of subspecies or varieties in plants. As you can see in the diagram on the slide, we conceptually compare these levels to biological taxonomy, but it's important to remember that there's no direct correspondence between them, even though the words are the same.